Scott's family has been involved in the California road construction industry for 3 generations. Scott grew up in Santa Barbara, California, and received his business degree from Cal State Fullerton with a minor in manufacturing technologies and geology. For the past 24 years, Scott has been involved in technical sales, marketing, and field engineering support for many special asphalt technologies and coatings, including scrub seals, lust tracking tack, chip seals, CRI, and FDR, and glow-in-the-dark submarine paint throughout the lower 48 states. Scott served in the industry as co-chair for the Pavement Preservation Task Force Group, PPG, Innovations Committee for 8 years, and is also the past president of the California Chip Seal Association and current board member of the Western Regional Association of Pavement Preservations. Scott?
Wow. And the glow-in-the-dark submarine paint actually was my first product I actually developed for a company called Ocean Engineering in Santa Barbara. They were having submersible dive units that were getting cut up in welding units, and the CIA wanted to make them glow in the dark. And they came to me one day and said, "Hey, how do we make something glow in the dark?" So I'm one of those guys that's a creative guy. I'm not that engineer in the box, and they had to change my name to Mikey because I'm like life cereal. Mikey likes it. Mikey will try anything and everything one time. And so I've tried a lot of new technologies, and I've had failures and had successes. I've always learned more from my failures. So I'll speak from some of those failures, and I hope to talk about a lot of the successes, though, too, because the successes is what you guys will take home from this. So congratulations. You guys are all successful because what is it? The last day of the conference, we have Nashville. Broadway's just a couple miles, less than a mile away, quarter mile away to Tootsie's. You guys are to be commended for still being here. So, how many people are familiar with slurry seals? Raise your hand. How many people are familiar with microsurfacing? Excellent. So everyone's familiar with it. I'm not telling you anything new. How many of you guys seen this picture before for the last 25, 30, 40 years? Exactly. So what we're going to talk about, though, is what's changed in this, the emulsion. There's been dramatic changes in the last 10, 20 years in chemistries and formulations and polymer modification. Great changes in mills and manufacturing technologies and chemistries and computerized systems. So we have had a lot of changes. We don't really maybe recognize those changes, but the one thing we never changed was our specification. We've been living with the same CSS, SS1H specification for the better part of 40 to 50 years, I'd say. We're still using the sewing needle to determine pen and trying to figure that as some determining factor of, wow, that's going to perform because that sewing needle went into that material. You know what, I can poke a sewing needle into my skull and it kind of hurts, and it's not going to tell you how great performance is going to be. So let's go with, we're also going to talk briefly about rocks and aggregates and what changes with those, and how we're going to start using some RAP. And how many people went to the RAP presentation on RAP maintenance techniques? Okay, so I'll have to hit on that. We also have water. California with the drought, the agencies are now demanding that you use reclaimed water. So you can't use the potable water anymore. So we're having the difficulties of trying to figure out how do you manage that in your business. You have additives in different chemistries. So a lot of things are here changed. So unfortunately the picture doesn't really change, and everyone kind of assumes that there wasn't much advancements, but there were a lot of advancements. So one picture's worth 1,000 words. And so really, when you look at this, I want you to imagine that road that Caltrans showed it beautifully in their first presentation, that I-80 with that 3/4 inch rutting, studded tire, chain wear. We see this out west from California into Oregon into Washington into Nevada into Utah. It's a constant problem we have, chain wear just beating the roads, smashing out the aggregates, causing some rutting. Stable road, great performing roads, highly modified roads, concrete roads, asphalt roads, these chain wears just beating the road to death. So here's pavement preservation, though, in a very harsh environment. Think Lake Tahoe, maybe think the Grand Hyatt right across the lake, Lakeshore Boulevard, 70,000 cars a day, and this is what you see. This was for Washoe County. They said, you know, we want to start a maintenance program, and we're not doing that. We're doing mill and fills, and every 6 to 10 years, we're milling and filling and we just can't afford it anymore. So to make the case for pavement preservation, we've all heard it, but this picture really just says 1,000 words. This right here was a conventional slurry seal, type 2 aggregate, 2.5% latex, put down with a conventional slurry machine we know today. Conventional microsurfacing, polymer modified, same aggregate was used in both roads or both lanes. And then we had this over a pavement that had been 4 years old. So we had some slight rutting because of the chain wear, but stable, no cracks. 6 years later, in this really, really harsh environment of Lake Tahoe, 21 feet of snow annually a year in certain locations, multiple freeze thaws. Wouldn't be unusual to see 3 or 4 freeze thaw cycles during the springtime. So that's really giving you that performance. But what we see there is one product has more polymer in it. So this is really going to be the evolution of more polymer, and how does more polymer help you in your durability? Just a little close up there. But I think that builds the case of pavement preservation. We could probably just drop the mic and walk out like, who was that Kid Rock the other night there? Just dropped the mic on the street and walked away after he sung a half a song. It was quite exciting. NCAT. Let's go down to NCAT and National Center of Asphalt Technologies. Right now there's a concurrent presentation going on with Buzz, who's given an in-depth process. I'm going to steal 4 of his slides though. Obviously NCAT, we have the heavy vehicle simulators running around the track. These trucks go around so often that the frames actually break and they have to re-weld them. So the trucking companies are learning a lot about durability of trucks and left-hand turns. So there's NCAT, and you can see that each little test section they got, test section, test section, test section, each little sign there's another test section. Well, we got some maintenance treatments out there. We also have some thin blanket overlays. We have some full sections of polymer modified, different asphalts and different modifiers. We have Lee Road 159. You got to learn about that. If you haven't followed that, make sure you go to NCAT and learn about this process. It really shows the value of pavement preservation. Most of the treatments we saw yesterday are all been placed down there and are performing pretty exciting. That's a low volume roadway, and then we're taking them out to US 280 for high volume roadway treatments. So I think everyone's familiar with that, but if you haven't, check it out. But what we did learn from that process is promote real innovation for the industry. So when we took that information, we said, God, what can we learn from all this research we heard and we saw? The one thing that the guys in my back room learned, and I know other people have been thinking about it, but we really gleaned from this is cracking on this far side here. And with that cracking, we also see loads tell crack propagation. And I mean, these guys go out in little tools, and they're rolling around on the roadway, searching for little hairline cracks. He's a crack master over there. And so we're actually looking, and we see right at 10 million easels, we started to see some crack propagation. But what we see here is, here's a highly modified, high mod, same aggregates being put down, and we don't get crack propagation until 15 million easels. That's quite an extension there. I mean, that's saying the value of polymer modification is really huge. I mean, there's a lot there. But we're also seeing, look at the amount of cracking that occurs and the speed of cracking that occurs versus that. That's a huge delta there. So we take that and say, well, how do we apply that? I mean, this is great. This is dense graded pavement, but how do we apply this to maintenance treatments? How do we go from paving and $1 million a mile to something that, how can we learn and put that to pavement preservation? So we do this through pavement preservation, looking at taking that high mod technology and try to extend those lives, move those curves right, most cost effective way in thin versus a 2.5 inch or 1.5 inch mill and fill. We'll talk about that one later. So what's new and exciting with polymer modification, and how do you get those into maintenance treatments? A 4% polymer modification is really, gets sticky, it gets gooey, it gets gummy, it doesn't do well, it's hard to work. So how do you get something from 4% up to 6% and get performance? very difficult. Hard to emulsify is SBR. Historically, some of the Nova chip, Nova bonds, the polymer modifieds for the ultra-thin bonded wearing course, we're about 3% modification. SBS latexes, they're great, very effective, but once you start getting into 6% of that, or having to go to 8%, you start having the chemistries of those latex emulsions override the chemistries in the polymer modification. I should say, overrides the emulsion. So, and then you also have the performance from lab to field, very difficult. So I take a sample from the lab and I send it to the lab to get it certified. I send it off to Caltrain and say, guys, get me certified. And they say, great, we'll certify you. We're gonna first heat this up. We're gonna do distillation. We're gonna distill this wonderful emulsion you sent us, 500 degrees, pull it all out. And we're gonna test this material and see if it meets spec. But where in the roadway and construction do I get a 500 degree day? I just haven't had that. So I don't get to do this distillation process. The real distillation process we have is what God gave us, the sun. And so how do you get a low temperature and use low temperature distillation to better mimic what we really see in the field? So we've come up with some low temperature distillation evaporation processes, doing very thin films, letting them naturally evaporate, keeping it in an oven, keeping them, I think it's below 180 degrees. So, and that's what the hottest temperature I think I've ever seen on a surface temperature, right about 180. That's in Palm Springs when it's 121 degrees, and I'm not quite sure why I was out there. So this might be a specification for the future. And this is really looking at, you look at that spec, what do most specs for emulsion have for microsurfacing or CQS? Number one would be pen. Want to know how hard it is, and that pen range would be between 40 to 90. We don't have a pen spec here. One might put a torsional recovery, a boiling point or a softening point in a specification. We don't have that in here. We do a low temperature distillation or this evaporation process, so we're not age oxidizing the pavement. So we're trying to truly mimic something that occurs in real life. Now this one here, I'm going to tell you, these guys in the back room, you guys with that DSR machine and creep recovery, he tried to give a slide and I won't try to build on it, but there's several experts in the room here. Codron here, obviously Massachusetts is very familiar with this, that they could kind of address most of these issues we have here. Softening point's typical for a lot of polymer modified materials, but it only tells you part of the story. Elastic recovery tells you part of the story, but it only tells you that you have presence of polymer at a 500 degree distillation. The elastic recovery process here, basically, you stretch the dog bone out and you cut it and you measure the recovery. It tells you if you have polymer or not. Problem is though, is with this test here's the polymer, this right here, we're just getting a little wishbone. The geometry is completely wrong compared to using a DSR. So if we don't have to take our sample and change geometry, this really doesn't give you a lot of meaningful data. I haven't seen too many roads that get stretched out this far. If they do, we have another problem. It's usually called San Andreas Fault. Other elastic materials behaviors, we're pulling it, seeing the strain, we'll see flexibility. Well, if we don't do that, our roads, usually we don't pull roads too much. Don't pull the rock out. Usually we have little micro strains. It's little pressures. It's a tire just zipping over a road at 60 miles an hour or going over at 5 miles an hour. It's a very quick strain, very quick release. So how do we better mimic that? Well, that's by using the Massacre and the DSR, and I have these slides in here, so if someone wants to read them, they can go look them online, and this is really to save some time here. But ultimately what we're looking at here is we're going to put a small sample on the DSR, run the Massacre at a frequency sweep, 10 cycles. What this does is it basically puts a little microstrain at a temperature, and it's simulating the recovery. So we want to measure This is where I'd invite you to, if you have questions on this, to talk to Codrin, who's right over here. We want to measure, here's the frequency of the strain, and here's the recovery. That's going to tell us, this slope here is going to tell us the modification. We're going to continue to do this multiple times, 10 times, so now we get a good average. Because that dog bone test, we have 2 samples, we pull it and we cut it. Well, I have 2 samples and 2 averages. Do I fail or not fail? I don't have a lot of statistical capability except rerunning the test, redoing distillation. Here's that presentation a little closer there. We're going to measure this, then we're going to watch this recovery, and this is the recovery of the method. So we're trying to determine this slope here is critical for the recovery. But what does that mean? We have this turn, microsurfacing. One of the big complaints we get a lot with agencies, cities and counties, inner city, is power steering. Man, I did the street, we did the parking lot, we have parked cars, and I have power steering burns. And so every agency that does it on a consistent basis is trying to warn the public, saying, well, you know, be careful, drive through, but, you know, really don't just crank on those tires. Don't tear it up, be gentle. It will get better next year. Let it go through the winter, it will get stiffer. And they always do. They always get better. But agencies don't like to have to explain that to the traveling public. So if I can reduce it by 80%, that's a huge reduction. And so by using the massacre test and turning that to torsional recovery, it turns very much into, if you turn your car tire 10 times back and forth, what might it look like? Here's a conventional, and here's the high mod. Same rock, same oil content, same trucks, same crew. But really what it tells you is that highly modified material gives you that resistance to the early traffic, the durability. So by utilizing this new test method and protocol, we can kind of determine what that softening point was. Now, technically, historically, microsurfacing might have a softening point 140 on the high side. With these specifications, we can get the softening point up to 160, 168. So it's just creating a tougher, harder, more durable mat right in the beginning when it's the most tender, when it's its most fragile state, right in construction. Just another sample of what it is. What it means to a cul-de-sac owner is this is historically in California and our land of great cul-de-sacs in Irvine, this is historically what would be acceptable to an agency in Irvine, California, 3 days to 2 months after a project got done. You can just see this loose aggregate on top. The trash trucks that we have coming in, well, they're all overloaded. They love to sit there and do a 5-point turn at the end of the cul-de-sac. It's usually in the middle of the summer when we do our good projects, and so the trash trucks are tearing up when they're hottest, most tender point. With a high mod micro, same aggregate, cul-de-sac right across from each other, just showing the same traffic concept, same garbage display, no sweeping there, reducing the need for sweeping about 80%. Now we go up to New England. So that's what we find in California that's critical. We go up to the guys in New England and Northern California, and their complaint is snowplow damage. How do I get my durability up? How do I get snowplow resistance? The plows are taking it off, the plows are scarring it. The delaminations from the plows, harsh environment. So we have some testing we're trying to develop for that, trying to set up specifications. So this would be some new technology on the mixed design side. If you did a slurry or micro design, this might be your new side on this. We're going to use the Catabro. What the Catabro is LA Rattler. Every agency that has a lab, has a rock lab in there, has this test. It's just a LA Rattler. Everyone knows it. Everyone, raise your hand if you know this one. That's my first job in the lab, was running this thing. So if you don't know, I can't really hear all that well because of this, but with that, we're going to put the sample in there. We're not going to put the charge medium in. We're just going to put the sample in. It has a paddle. If you've never seen this, it's just a drum with a paddle. No charge medium at all. We're going to let this run 300 times. for the Gatabro or Cantaburo, depending how good your Spanish is or not. That's who developed the methodology. We're going to put our sample that we've compacted with a gyratory compactor into the Gatabro. We're going to let it run 300 revolutions, and we're going to measure the loss. So what does it look like 300 revolutions? Well, here you are with the durability. This is a traditional CQS, slurry seal, non-modified. Then you have your traditional micro, could be 3.5 to 4% modification. And then you have the high mod, which is probably up to 6 to 5.5, but we're not worried about the percentage of polymer because we have a good test procedure to identify this durability. So same rock in this case, every one of these, same type 2 aggregate, nothing's different, same asphalt content, one's higher, nothing like that, same residue, put in the Gatabro. So which one do you want on your roadway? Which one has the possibility? Now, if you think about the improvement, we go back to that first picture up in Tahoe, and we saw that CQS slurry with some abrasion. It was time for a micro on top of that. We saw the micro performing, but with the high mod, we're not seeing the damage there. This is the expectation of maybe 3 to 4 years longer life, going back to NCAT, where we saw that extension in traffic before we saw fatigue cracking or cracking developed. This is what we expect to see with this. Just some other samples. So this goes to a slide when we're doing some work up in New England. I guess it was Dartmouth in Massachusetts, did a nice project, did a fantastic project. And they went and looked at several different deals. They said, we have some plow damage. How do we address this? We need a control section. We're going to add some different fibers. We're hearing the fiber people are saying that it can reduce cracking, it can increase durability, and those little fibers would help us with that micro abrasion. And so we'll put some fibers in there. We'll try two different fibers. We'll try a polyester, we'll try a fiberglass fiber, and then we'll try just a high mod. So here's those Canterbury results in a graphical presentation. And if we go up there and today, and I've gone back there, it's a good section, it's a good test section. We had 2 different machines, so we might have had some equipment issues, but we're pretty much seeing what this result here tells us is what we're mimicking in the field. We are seeing one that's performing much better, the high mod. The other polymers or the fibers are performing very well, and the traditional micros performing as they expected. But we are seeing some differences. This same test result, I believe it's down in Westchester, down in Connecticut, is also being mimicked again. And the contractor is stepping up and said, I'm going to take out the deviation of the machine and use one machine and do all the processes again, just to verify what he had, to take out any construction bias. There's the first report. This was in 2013 when they did this project. Been out there last year, looked at it. Getting ready to go back out and take a look at it again with another group and see if we can't get it right up and have a meeting with the agency. But they were here this week and talked to them, and they say it's just performing fantastic. The only complaint they had on the whole project was the color of the aggregate. They had a rock that was used that was traditionally kind of a pink rock. And so when the plow came and they did abrade it, this pink hue came up, and the paving rock that's mostly performed out there is a very dark granite. And so they look at it and say, well, God, my road turned pink. And so we said, well, that's easily fixed. That's just a function of spec'ing the color of rock and going with a darker rock, spec'd out the darker rock, and they haven't had any issues last year or this year. Everyone's really very pleased with it. Once again, looking at that specification, you don't have pen, you don't have a softening point. What do we have there? We have we got a sieve. Okay, there's a traditional one. That's siev's important. We have a residue, that's important. We have an original DSR. That's unusual, never heard of before. So this is a completely different specification in this process. And so if I tell you something, I show something twice, it's really important because that's how I just tell people that if I said it twice, it's very important. This is a different specification than what we see out there in the marketplace. using the DSR. Different test procedures. If you have some questions on that, be more than happy to answer those later on. One thing that must be done is it has to use an augered box. The viscosity on that material is significantly different than the other microsurfacing and other emulsions, so you have to use an augered box to keep that material moving. The only projects we've seen with difficulty in the learning process was the 4 contractors that we said, please have an augered box. Didn't show up with an augered box. The augers didn't work. They struggled. It dragged. It built up in the box. So augered box is key to the success of utilizing these highly modified, high viscosity materials. There's a good comment you can read. He believes in it. This was a comment I think he got in 2013, and he still sticks by it to this day, that we are seeing increased performance, increased customer satisfaction, reduced rattling. The cost varies on thickness, could be 20 to 29 cents more per square yard. Expected increase, we hope to see 3 years. We're only at 2013, we see 3 years of performance, but we do expect to see it with the Catabro results and the power steering results. We do believe we'll see that increased benefit, because most slurries fail, or micros fail, not because they ever failed, they pass initial construction, they just wear out, they get thin. We're already showing you a wear test. I think it's pretty exciting. Will get us there. Things we have going on: Massachusetts, coast to coast, Connecticut, Texas, Big Bear, California, snow environments, hot climates, cold climates, low climates, hot, humid climates. We're getting everything covered. Now, what's next? What's the other complaint we get? Oh, slurries and micros, they crack too quickly. Yep, they just crack. I mean, I put them over a cracked up pavement. I'm not quite sure why we're putting them over a cracked up pavement. We don't recommend it for cracked up pavement. It's keeping good roads good, right? But, so we're looking at now, and the boys in the back room are doing a fantastic job looking at this, is they're taking a modified Texas overlay tester, and which applies a strain to a sample of aggregate. And this is what we're seeing with a slurry. We're getting to this cycles here. With a micro that's modified, we're getting to these cycles here. And then with eFlex CR, which is a crack resistant, what we did here is increase the asphalt content. These are not all equal, but I think they may be all equal in the asphalt content for this testing parameter, but we went with a higher asphalt content across the board to get the most flexibility we could in these results, and we're seeing this huge gain there. But so that's neat. We have a laboratory predictor. Now we had to take these predictors, move them out in the field. We did some projects down in Texas in some alleyways and some parking ways near some schools, and had some buses loading over it. And so we're monitoring, and we have a team out there that is doing a fantastic job evaluating the existing condition and going back on a regular schedule to review it. But what we're seeing is the crack reflectivity is reduced dramatically. This is something we saw in Utah when 2013 we did it. 2016, historically, these working cracks, or these cracks here, you'd start to see spalling. You'd see them back at the same size. We're not seeing that after 3 years. So we're seeing great adhesion, wall adhesion, great durability. Is there a hairline crack there? Yes, there is a hairline crack. But if we had that in a controlled section next to a regular conventional slurry or micro, I guarantee you that crack would be looking more like that after 3 years in the Utah market. So we're very excited about that performance. Obviously, we do lots of projects comparing different products. This is just a project map showing comparisons, map cracking, checking out all the cracks, documenting, seeing what we have. This is up in Victorville, the high desert. We get a lot of freeze thaw. It wouldn't be unusual in Victorville in October to see temperature 100 to 98 degrees, and the next day at night be 32. So we get huge temperature swings, lots of thermal crack, lots of moving up there. So we're evaluating that road, and hopefully we'll give you some great data and some great perspectives here in the future. Now we're going to move to the ground tires. I had a lot of things I professed we'd talk about today, and we're going to move out of those. We're going to move to the additives, into that aggregate section we talked about. And so we have the ground tires in California. I mean, our legislators are just crazy. It's and high legislator. You can watch it on the film here. They are just cuckoo about Cocoa Puffs and ground tires. They want ground tires in everything. It's a mandate, preferential points. You get engineering credits back. I mean, you'll get all kinds of crazy things. So everyone's trying to figure out how you put ground tire rubber in your mix. So here's 3 ways that are in slurry and micros that we can do, that we are doing currently throughout the state. We have 5% by weight of emulsion added at the machine through an extra fines feeder. We have 5% blended into the aggregate. We have 5% GTR, which is a terminal blend asphalt, being blended into the asphalt. So you got 3 ways of getting it there. LA County and San Bernardino County, Riverside County, San Diego County all consider all 3 methods acceptable and legitimate methods of getting in there. So there's no proprietary or issues around that. It's whatever the contractor's choice is, but here's 3 options. Meets the recycling credits, makes us feel good. No mixed performance or benefits have ever been proven. I think that we did some original research when I was over at Coke that we kind of found that 5% was the maximum. Anything over 5%, we saw negative results. At below 5% levels, we didn't see any additional benefit, but we didn't see any harm. So I'd say that if you get cuckoo about Cocoa Puffs and tires, 5% or less is a reasonable thing you could do, but you're not going to see any great performance. There we go, making those tires. Want to use a very fine mesh, 30 to 80 mesh ground tire. We don't want to use anything larger because of the rebound effect. We want to really just use it as a mineral filler or a filler into the aggregate gradation. Here's an example of blending with the aggregates. You have 100 grams of rock. You have 5% weight. You blend the 2. There you go. I guess the only visible difference is one looks a little darker maybe on the right, maybe, but not noticeably. Here's that extra fines feeder, adding it into the Pug Mill. This process works really well. I think 4 or 5 contractors have adopted this process. They added here, added fines. It's easily measured. It can be easily inspected. It can easily be verified. So that's a good way to do it. City of Ontario, they've been putting out a program for the better part of 10 years, almost maybe 14 years they've been doing it on there, and they like it. They also have a requirement of carbon black, so it looks very black. Here's the process, terminal blend process, done at the refinery and or at an asphalt terminal, where they take the ground tire rubber, melt it, put some high heat to it, and basically carbonize it into the asphalt, so you can get a weight certificate, get it in the asphalt, and put it down. And that's a process that done a lot in Texas, done a little bit in California. Terminal blend, and there it is going down the roadway. It's the product that's in front of my house. So I give you the effects that anytime you use tire rubber, you need to use a rubber tire roller. You need to have that compression, that rebound effect that you get during the coalescence stage of the emulsion. Seems to cause us some problems, some moisture sensitivity issues and early raveling. When we use a rubber tire roller, those issues seem to go away. So highly recommend, if you're going to spec that, look at some of the California specs. They all require a rubber tire roller be placed on top of it. City of Port Hueneme. Now we're going to move to wrap. This is probably the one thing I think this is pretty exciting. This is a project that they do. They've done 3 years in a row now. They've done high mod. They went to the high mod. They liked it because of the raveling resistance. And Port Hueneme is doing some great things up there. The wrap is performing great. Yes.
Slurries and microsurfacing, you roll?
Well, when you're using, now be very careful, when we're using a ground tire rubber, the rubber itself, those little small particles have that rebound effect. And when you're building that cohesive state and you're in that tender zone and you're getting that, if you don't roll them, you don't build that cohesion around that ground tire rubber particle. And
How long, when you, what's
the same day,
initial rolling after?
2 hours, 2 hours, 4 hours, same day. And we just see an, dramatic increase. I can show you in front of my house, and the contractor didn't do it, and it's gone. I mean, it's an embarrassment. It's 5 years old.
I only asked you for the quality.
Yeah.
Yeah,
Where he did it on the other street next to mine,
yeah.
those neighbors are real happy. They love me over there, and my neighbors are like, what the hell did you just do to me? Millings. So when we're going to take about wrap millings are best generated if we're going to use wrap in our recycled, in our slurries and micros and or chip seals. They are best captured from the milling machine. You do not want plant waste mix. You don't want cutback. You don't want patches. You want the stuff that comes off that road. So if you do a 1-inch mill and fill, that's the product you want to capture, that top 1 inch. We're going to take that material, we're going to fractionate it. And when you're fractionating it, this is kind of what you see is you produce about 45% of that pile when you put the crusher on it. It's going to produce a chip rock, kind of a 3/8 rock, a little bit finer than 3/8, almost a 5/16, similar to your maybe 8s or 9s. Then you're going to have your slurry dust, about 50% and 5% other. That's going to be cords and rips and crack sealant and different things that will pop off the other side. When we're going to do that, you're going to fractionate. Here's the plant just running. It's running all his different materials he's producing. So if you can have a balanced effort, if you're going to do some chip and some slurry micro, you can have a very successful program. Obviously, the weights and viscosity measure up there. Just you don't want to build your stockpiles too early or in the heat of the summer. We're lucky in the West, in California and Arizona, that our pavements fail because of age oxidation, not due to thermal fatigue. So our effective binder on these wraps, I mean, if you did absent recovery and viscosity, we're down to, 1 million seconds, 3 million seconds. I mean, you could sit there for days and never get to go through that viscosity tube and say, I think we're done. It's black rock. With that, I covered 60 slides in time. Good deal. So if you're confused and you feel like that sign, which way to go, feel free to give us a call. We'll try to straighten you out in the path and narrow. I just gave you 5 different presentations in less than 35 minutes, so I apologize for that too. But they wanted to get big concepts, so there's big concepts. Thank you very much.